Okay, we've all been there, right? You're in a high-stakes coding interview, and it just goes completely off the rails. Well, today, we're going to walk through that exact nightmare scenario, but with a really interesting twist that completely changes the game. Just picture this for a second. The cursor is blinking on the screen, just mocking you. The interviewer on the other side of the Zoom call is just silent. This is where our story kicks off, right in the middle of a full-blown panic, with a dream job hanging by a thread. All right, so let's rewind and set the scene. This wasn't just any interview. Nope. This was the final round for a senior data analyst spot at a top tech company. You know, the kind with free lunch and rock climbing walls. After acing every other stage, it all came down to this 1 hour. This live technical screen with the lead data engineer, the final boss. The setup seems simple enough, you know? The interviewer shares their screen and shows two basic tables, customers and orders. You can see the schema here. It's pretty standard stuff. You've got customer ID linking the two tables. It all felt pretty straightforward, almost like a gentle warm-up before the real test. And then came the question. Find the top 3 customers by total purchase amount, but for only those top 3, also return their total number of orders and average order value. Now, at first glance, that sounds easy. But that little twist, calculating more stats for only the top 3, that's the trap. It's a classic, easy to say, hard to code kind of problem, and it's designed to see how you handle complexity when the pressure's on. So, feeling maybe a little too confident, our protagonist dives right in, ready to just knock this thing out of the park. But that cleverly hidden trap is about to spring, and it leads to 3 very distinct and pretty painful failed attempts. So, what's your first instinct? Probably the most direct one. You join the tables, you group by customer, you order by their total spending, and you just slap a limit 3 on the end. And yeah, this gets you the names of the top 3 spenders, sure, but it is a complete dead end. Limit gets applied at the very, very end of the query, so you have no way to go back and run more calculations on just those 3 people. And this right here, this is the heart of the whole problem. This is the question that causes the mental block. The simple, direct approach has totally failed, and now the pressure is really on to find a more sophisticated way to isolate that top group before you do the final calculations. Okay, plan B, a subquery. The idea is you write a query inside your query that finds the top 3 customer IDs, and then you use that little list to filter your main query. But as soon as the code starts appearing on the screen, it feels wrong. You know that feeling? It's clunky, it's hard to read, and you just know it's a performance nightmare because you're basically scanning the data multiple times. All the while, the interviewer just nods, giving absolutely nothing away. The silence is deafening. All right, delete that mess. Time to bring out the pro move, a common table expression, or a CTE. This feels cleaner, right? More advanced. You use a with clause to create this neat little temporary table of the top 3 customer IDs. But then what? You're right back in the same logical loop, trying to join that small list back to the main data. You haven't actually solved the core problem. The brain is just buffering. Now, what's so wild is watching how that pressure just builds and builds. We're 45 minutes into a 60-minute interview. All that's been produced is a pile of deleted, failed code. The panic is really starting to set in. With that clock ticking down, it feels like that dream job is just slipping away. And just as they're about to throw in the towel and admit defeat, a memory flickers. A tool a coworker mentioned offhand. Some kind of AI that translates plain English directly into SQL. And this leads to a huge critical decision. Do you risk it? And this just sparks that classic internal debate. Is using an AI tool cheating, or is it just being resourceful? I mean, the interviewer did say it was an open internet test, and to use any resources you'd normally use at work. At a real job, you'd be on Stack Overflow, you'd check documentation, maybe you would use an AI. The real goal is to solve the problem, right? The decision is made. It's a calculated risk. So, with this new sense of purpose, they open a new tab, navigate to the AI tool, in this case, AI to SQL, and get ready to translate their problem from plain, frustrated English into perfect, elegant SQL. So, this part is absolutely crucial. The AI is only as good as the question you ask it. They didn't just type, solve this SQL problem. They were super precise, laying out the request exactly as the interviewer had given it to them. Find the top 3 customers with the highest total purchase amount. For these top 3, return their name, total purchases, total orders, and average order value. And in seconds, the AI spits out this beautiful query. The key to its elegance is something called a window function. Now, unlike a regular function like sum or count that collapses a bunch of rows into one, a window function can do a calculation, like a rank, across a whole window of rows while keeping all the original rows perfectly intact. This is the breakthrough. So how does this actually work? Well, the AI's logic builds it up in a couple of steps. First, it uses a CTE, let's call it quarterly orders, to do all the heavy lifting. It calculates the total spent, the number of orders, and the average order value for every single customer in the database. Just crunches all the numbers in one efficient go. Now, here's the master stroke. A second CTE gets built right on top of that first one. It selects all that great data we just calculated, and it adds one more magic column using the dense rank window function. This function just looks at the total spent for each customer and assigns a rank, your number one, your number two, and so on, without throwing away any of the other data we need. This is how you solve that find them first problem. It's brilliant! So, with all the data now calculated and perfectly ranked, the final step is incredibly simple. The final select statement just takes those results from the ranking CTE, joins back to the customers table to get their names, and then just filters for customer rank less than equal to 3. That's it. It's clean, it's efficient, and it's scalable. It's beautiful. Now here's the smart part. They don't just copy and paste the code. They take a moment to actually understand the logic. Then they start typing it out themselves, explaining this superior approach using CTEs and a window function as if they just had this brilliant breakthrough. And the reaction from the interviewer says it all. This silence is finally broken, not with disappointment, but with actual praise. They recognize the advanced, efficient pattern immediately. The entire vibe of the interview just shifts from a tense test to a collaborative professional discussion. About a week later, the phone rings. The interview was a massive success. The risk totally paid off. They got the job. So what's the real lesson here? Well, this whole story shows that being a great data analyst isn't just about what you've memorized. It's about being a great problem solver. And AI tools aren't just cheat codes. They can be these incredibly powerful collaborators that get you unstuck and, maybe more importantly, actually teach you better, more efficient patterns that you can use for the rest of your career. And that really leaves us with a final thought to chew on. In moments like this, when we hit a wall that we just can't seem to get over on our own, is a tool like this a crutch that just stunts our growth? Or is it a ladder, helping us climb higher and maybe even showing us a better way to the top in the process? Something to think about.